Hello and welcome back to another video from our MATLAB for Chemistry video series. GPU acceleration allows you to analyze massive chemical datasets in a fraction of the time required by CPU-based methods. In this video, we demonstrate how to implement a MATLAB RDKit molecular clustering workflow that leverages GPU acceleration specifically for the pairwise similarity computation step. If you haven't already, check out our previous video on molecular similarity analysis and try that example. Understanding concepts like Tanimoto similarity is crucial for getting the most out of today's workflow. Find the links to the previous video and its GitHub post in the description below. In the previous example, we explored the concept of molecular fingerprints as binary representation of a molecule's structural features such as substructures, functional groups, and atom connectivity. Using a simple example with aspirin and acetaminophen, we learned how to check for the presence indicated by 1 or absence indicated by 0 of specific features. We saw that using this simple approach, it allows us to convert complex structures into machine-readable vectors. In that example, we learned how to use such vectors to quantitatively compare molecules by calculating the Tominoto coefficient. As you can see in this table, the Tanimoto coefficient is calculated from the intersection and union of the two vectors. Although this is a simple idea to implement, but the conventional for loop that we used in the previous example for pairwise similarity calculations raise a challenge. As you can see here, this approach loops over every pair of molecules, and every time it calls an external function to compute similarity for each pair and store the values in a symmetric similarity matrix. And that is where we face the computational bottleneck, because such for loop approach is a very slow approach for large datasets. In today's example, instead of using a for loop, we take advantage of GPU accelerated parallel computation. In 3 steps, we move the fingerprints to GPU, then all pairwise similarities are computed simultaneously on GPU, and finally the results are moved back to CPU. You can learn more about GPU computing in MATLAB using the link provided in the description. Before we move forward, remember that you can always run something like this MATLAB code to quickly check the GPU availability on your machine. The GPU computation starts by gpuArray, which offloads the fingerprints to the GPU. gpuArray in MATLAB is a data type or object that represents arrays stored on a GPU, which enables GPU accelerated computations. See the link in the description to learn more about MATLAB gpuArray. While our data is on GPU, we perform all linear algebra and bitwise operations such as summation, multiplication, and division on thousands of CUDA cores compared to a few CPU cores. This means we compute pairwise similarities all at once, not sequentially as happened previously using the for loop. Finally, we need to transfer the data from GPU to CPU. Gather is a function in MATLAB that transfers data from a GPU array on the GPU back to the CPU memory, converting it to a regular array. Learn more about how gather works by following the documentation link in the description. Please open the example using the GitHub link provided in the description and experience the massive speed up you get when you run this example on GPU compared to the CPU runtime. This live script example starts with an introduction to the problem, then it gives you the instructions for the requirements, how to import and prepare molecular data, how to generate fingerprints, and move it to GPU to compute pairwise Tanimoto similarity matrix on GPU, and move the results back to CPU. You can then visualize pairwise similarity distribution or bin molecules by pairwise similarities, and visualize molecules from the selected bins. The example closes by some conclusions and exercises to practice. As always, the exercises are easy to do and very practical. This exercise asks you to simply download the Tox21 dataset from MoleculeNet. Please see the link in the description. This dataset contains information about the toxicity of various molecules. Import the dataset into MATLAB, generate molecular fingerprints, and compute the pairwise similarity matrix using the GPU-enabled workflow from this example. Examine clusters or bins of molecules with high structural similarity. Do you observe recurring functional groups or substructures, which are usually referred to as toxicophores, in molecules that are classified as toxic? And compare these findings to non-toxic clusters or their structural motifs that appear to be associated with lower toxicity. Give the example a try. I hope you enjoy it. Thank you again for watching, and see you in the next MATLAB for Chemistry video.